Welcome back to GeoMethod, where we turn tricky geometry into clear, simple steps. Here is today's challenge. Can you find area and perimeter of the blue rectangle? Take a moment to look at the figure and see if you can spot the idea. Then stay with me and we will build the full solution together, one move at a time. The outer figure is the blue rectangle IBCD. We want both its area and its perimeter, and a single diagonal will unlock the whole thing. Two numbers are wanted at once: the area enclosed by IBCD and the distance all the way around it. Both will flow from one short length once we find it. The blue rectangle is paved by three identical green rectangles. Two of them stand at the top and one lies across the bottom, and their shared shape is the key that links the height to the width. The first green tile is the long rectangle FBCH along the bottom. It lies flat, so its long side spans the full width of the blue rectangle and its short side runs up and down. The second green tile is IFGE in the top right. It stands upright, so now the long side runs up and down and the short side runs across. The third green tile is EGHD in the top left, sitting directly to the left of the second. It is the same standing rectangle, placed to fill the top row. Because the three tiles are congruent, they all share one short side and one long side. Let the short side be A and the long side be L, so every tile measures A by L. The two standing tiles sit side by side across the top, each contributing its short side A to the full width. The lying tile's long side L spans that very same width, so L equals A plus A, which is 2A. So the width of the blue rectangle, the side BC, equals that long side, which is 2A. Up the side, the lying tile is a tall, and the two standing tiles are L, that is 2A tall. Adding them, the height is a plus 2A, which is 3A. So the blue rectangle IBCD is 2A wide and 3A tall. One unknown length A now controls the entire figure. We are told the diagonal BD of the blue rectangle is 26 units. That single measurement will pin down A. The diagonal splits the rectangle into two right triangles. Look at triangle BCD. The corner at C is a rectangle corner, so the angle there is a right angle. The vertical leg segment CD is the full height of the rectangle, so it measures 3A. The horizontal leg segment BC is the full width of the rectangle, so it measures 2A. And the hypotenuse segment, BD, opposite the right angle, is the diagonal we already know, 26. The Pythagorean theorem says the two legs squared add to the hypotenuse squared. So 3A squared plus 2A squared equals 26 squared. Take it one square at a time. 3A squared is 9A squared, and 2A squared is 4A squared. On the right side, 26 squared is 676. Add the two like terms on the left. 9A squared plus 4A squared is 13A squared, and that equals 676. Divide both sides by 13. 676 over 13 is 52, so A squared equals 52. Take the positive square root. The square root of 52 is the square root of 4 times 13, which is 2 root 13. Here is a useful shortcut. For the area, we do not actually need A yet. Since area is 6A squared, finding a squared is already enough to get the area. We only take the square root afterward because the perimeter needs the side length A itself. Now the payoffs. The area is width times height, 2A times 3A, which is 6A squared. Notice it depends on a squared, which we already have. Substitute A squared equals 52. 6 times 52 is 312 square units. The perimeter is twice the sum of the two side lengths, 3A plus 2A, which is twice 5A or 10A. This one depends on a itself. Substitute a equals 2 root 13. 10 times 2 root 13 is 20 root 13 units. So the answer is 312 and 20 square root of 13. And there we have it, clean and verified. If you like walking through geometry this way, do me a quick favor and tap the like button, then subscribe to GeoMethod so the next puzzle lands right in your feed. Have a slicker approach? Drop it in the comments. I read every one. Thanks for solving with me, and I will see you in the next one.